In this video, we are going to be looking at 10.3, Apply Properties of Chords. Now, before we start, I want to make sure that you realize where a chord is at. All of these theorems that we are going to be looking at today will be inside the circle because that's where a chord is located. So we're going to start out with several theorems. So the first is Theorem 10.3, and it states, in the same circle or incongruent circles, two minor arcs are congruent if and only if the corresponding chords are congruent. Now, you'll notice a lot of the theorems will read this way. In the same circle or congruent circles, and notice we have a biconditional, if and only if. So what this says is arc AB is congruent to arc CD if and only if segment AB is congruent to segment CD. So right here, this arc belongs to that segment, and this arc belongs to this segment. Okay? So since these are congruent, these minor arcs are also congruent. Moving on to 10.4. This one says if one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So let's look more closely at this one. If QS, which is right here, is the perpendicular bisector of TR, so it is perpendicular and bisecting, then QS is the diameter of the circle, and that's always going to happen. So if I can draw a circle here, and then I draw the diameter, and I put another little chord right there, if those are equal and perpendicular, then the first one that I drew was in fact a chord. That is Theorem 10.4. Now 10.5. It says if the diameter of a circle is perpendicular to a chord, like this one is right here, then the diameter bisects the chord and its arc. So let's look at this one a little bit more close. It says if EG is a diameter, and you can see this little dot right here, that's going to tell us that it is a diameter, and it is perpendicular, EG is perpendicular to DF, then HD is congruent to HF, and this arc and this arc, which will be arc GD, is congruent to arc FG. So these first ones, the 10.3 is kind of the easy one to remember. Congruent chords makes congruent arcs. 10.4 and 10.5 deal with the diameter of circles and perpendicular. So 10.4 is saying if perpendicular and bisect happens, then that is a diameter. And this one's saying if you have a diameter, then it's going to bisect, if it's perpendicular, it will bisect the chord and these arcs will be congruent. Now, moving on to 10.6. It says in the same circle or incongruent circles, two chords are congruent if and only if they are equidistant from the center. Equidistant from the center. Looking more closely at this one, AB is congruent to CD if and only if EF, which is right there, is congruent to EG. So that is EF is equal to EG. Now notice some notation. Equidistance means equal, so that means these will be equal. Why are they perpendicular? Remember, the shortest distance between a point and a line is the perpendicular distance. So these are congruent, then these chords are also congruent. Now, question 1 says, use the diagram to find the measure of arc BC. Tell what theorem you used. So if we look at both of these, we can see that we have congruent circles. Right there, we have the same radii. The next thing we notice is this chord is congruent to this chord. So we actually have congruent circles. So since this chord is intercepting 125 degrees, then BC is going to be 125 degrees by theorem 10.3. That was the first theorem we looked at. So we would say the measure of arc BC equals 125 degrees. Now, number 2 says use the diagram to find the length of BD. So here is BD. Tell what theorem you use. Okay, so the first thing we notice is we have this dot, therefore AC is a diameter. We also see that it is perpendicular. So by theorem 10.5, which is right there, 10.5, this one states that this portion is going to be equal to the other portion. So if this is 6, then this right here is 6. So the length of BD is going to be 12.